Hello students, welcome back. We went through some integration by parts, basically the use of this formula and this hierarchy table most of the time. We went through all these problems. First two were straightforward because they both came from the hierarchy table. This one was a bit trickier, but we could handle that. This one took a lot of effort, and we had to apply the integration by parts twice. Oh, here are more problems. Now, these kind of problems will have to combine the integration by parts and integration by substitutions. No, I take it back. This one and that one are, but this one is not too bad. It looks a bit intimidating because it doesn't look like integration by part because we have only one function here, not the product of two functions. But if you realize that this is the integral of 1 times log of x times dx. If you realize this, now it's easy. Because this is a power function, x to the k power, where k is 0. And this is a logarithmic function. So u is log of x, and v is 1. Which is x to the 0 power function. Then u prime is 1 over x, which is x to the negative first power. And v is x. So integration by part formula says u times v, so log of x times x, minus integral of u prime v, x to the negative first power, times x dx. So x log of x minus the integral of 1. So x log of x minus x. But then again, many people consider this as just a formula. Integral of log of x is x log of x minus x. A bit tricky to see, but the end result is so well known. After all, this is an important function, antiderivative of an important function. So if you look up, then you'll see the answer flying around. Go to Google search and then antiderivative formula or integral table or whatever. There must be the answer for this somewhere. Whether you can deduce it using integration by parts or not, that's a different story. What did I do here in my answer key? Yes, it's the same thing. And then u prime v, and then apply the integration by parts formula. And let's align these. Okay, how about the next problem here? This one is different, very, very different, because e to the square root of x function, can you find out derivative of antiderivative? Either way, too complicated. Another indicator is that this is a composite function, not just composite function, but rather complicated composite function. So we'd better take a substitution. Or in other words, x to the 1/2 power. excuse me. There you go. If I do that, then dy is 1/2 x to the negative 1/2 power dx. dx is therefore 2x to the 1/2 power dy 1/x to the negative 1/2 power. I'd much rather write it as 1/square root of x, and 1/2 power as just square root of x. And then square root of x is y, so 2y dy okay, all right. And then what do you have? The integral of e to the square root of x dx is the integral of e to the y power, and then times 2y dy. So the integral of 2y and e to the y power, y power dy. Yes, we ended up with a typical integration by parts problem. We have a polynomial function times exponential. So how do you do this? U is 2y, v prime is e to the y power, u prime is 2, v is e to the y power, staying the same. If I do that, then this becomes the integration by part formula, u times v, 2y times e to the y power minus integral of 2 times e to the y power dy. So 2y e to the y power minus integral of 2 e to the y power. Well, that's an easy integral. 2y e to the y power minus 2 e to the y power, and that's it. Exponentials stay the same. But be careful, that's not the end of the story. We have correct antiderivative, but that's written in terms of y. The original problem was written in terms of x, so we have to get x back. So 2 square root of x, square root of x e to the square root of x power minus 2 e to the square root of x power. Is that it? Looks like that's the solution. Integration by parts, integration by substitution, out up to here, and then integration by parts, and that's going to be the rest. Okay, so let's do it up to here. So substitution leads to up here, the first line, and the integration by parts. Okay, all right. Let's see. What does Mathematica say about this? So negative 2e to the square root of x power, yes. and then plus 2 square root of x times square root of x. Yes, correct. So everything fits. What did I do in my answer key? Substitution, and we end up this integral, and then integration by parts, u prime v, and then we get that, and then the final substitution. Okay, verification through Mathematica. Everything is here. Do I have enough time for this one here? Why did I de-emphasize it in gray? Integration by substitution, same as before. And then apply, put everything in, simplify, and integration by parts. Okay, I skipped what is u and what is v prime. U is 2y squared and v prime is exponential, and u prime is 4y here. And then we have another integration by part because we have polynomial times exponential. U is 4y, v prime is exponential. So u prime here and then v there. This minus changes sign, so minus minus plus. And antiderivative of this is e to the 4y like this, and we get the answer like that. And then you can verify to computer algebra system. Yeah, compared with this problem, it's not as bad, but still it's pretty bad. Okay, looks like I did make right decision on de-emphasizing it in gray. In any case, that completes all the problems I prepared for integration by parts.